Hi, good morning, class. Let's start by going over last night's homework. So we assigned 3 questions last night. Does anyone want to volunteer to come explain the first homework question? And so timeout. In the first 5 to 10 minutes of class, I'm going to have one student come up and explain one old homework problem per student, and that'll spur class discussion if the student got it wrong or if a lot of students still have questions over what we covered yesterday. From the previous day's assignment, we'll lead into today's work, which is learning how to calculate slope, how slope can be interpreted graphically, going off of data points, and how slope relates to real life and what its uses are. So what we're going to learn today is how do we find slope, why will you need to know slope in 5 years, and why slope is important to you. So just class, let's give some examples of how you've seen or experienced or witnessed slope just today. So slope can be the change in speed of your car as you were driving to school today. It can be your change in average grade on homework assignments as the year progresses. It can be dollars saved per month, dollars spent per month. Slope is nothing but a rate of change. It's anything that can be graphed showing a change generally with relation to time. So do we have a volunteer? I'm going to give a real world example of what slope is. Okay, thank you for volunteering. So stand up, and I want you to walk across the room. So the students will measure the time it takes the student to walk across the room, and then measure the square tile floors 1 foot by 1 foot, and measure the distance per time, or feet per minute, that the student walked across the classroom. That's my opening hook is, kinesthetic, get someone involved, have a timer, have class discussions on how the slope changes if he were crawling, if he were walking, if we were running, if he threw a ball, what those different slopes would look like. Next, we're going to get into small groups, 2 to 5, depending on how large class size is and how the room is arranged. And we are going to do, each class will find their own example of slope, if they want it to be feet per minute, dollars per day, haircuts per year. Whatever these students want to slope, they will give a real life example, they will model it if possible, they'll provide data points, they will graph it and show how that graph relates to an equation, all without calculators. This is all by hand. So we'll have our group work for 10 to 15 minutes in class, and when we reconvene, the students will give a 60-second discussion or presentation over what kind of slope they chose, why it's important, and just what they learned from it. So as these presentations are coming up, what I'm going to ask each group is to explain using the data sets and charts and tables that you made. Explain how your activity relates to slope. So why do these equations and why do these data sets you made relate to slope? And their answer will help prove that they know what fundamentally slope means. I think that's important because you can be given a huge list of equations and graphs all day long, but if you don't know what the equations mean, there's no point in finding the slope in something if you don't know what the slope is and why it'll help you. And then as a closing example to lead into tomorrow's discussion, I'm going to ask, okay, say for example, one of the group's projects slope that they found was y equals 5x plus 2. I'll ask, okay, what kinesthetic activity can you do that'll represent a perpendicular slope to that? So first off, there'll be a discussion on what is a perpendicular slope. So it would be y equals the negative reciprocal. Y equals negative 1 over 5 plus 2. And they'll have to brainstorm for the next day's work what a negative graph kinesthetic activity can be. And we'll close with those discussions and close with group presentations. And that is my 5-minute talk. Thank you.